about a session that I came up with rather spontaneously for the reason that Tom cancelled his attendance for well-known reasons. I like to, so there's these blocks where you basically explain what you did 1 or 2 years ago, and that's, it's very exciting and so on. So I enjoyed that tremendously on Monday. But I like actually more to do blocks where I'm sort of discussing things that I'm planning to do the next year. So this is sort of unfinished work and really starting. So so my session this morning will be more of a discussion and brainstorming session and trying to understand the problem than showing solutions. Yes, and I think it's relevant. So it's basically triggered by Mike on Monday, right? Who said, the Antarctica is not easy to do and has gone through great lengths and so on. And it's really not easy to do for the wrong reason, I believe. And so I've been writing, plot methods for spatial data since 2003 or so in R, and you have to make certain decisions and choose defaults and these kind of things. And basically what we do there is continue doing what everyone has always done, and that is essentially treating the world as as two squares, and rather than anything else. So that actually has a name. Yes, it means basically that you take longitude and latitude data, and just say I'm going to plot latitude along y and plot longitude along x, 1 to 1. Yes, and then you end up with a plot that is exactly two squares, and that's why it's called plot carré. And it's the generic term is equirectangular projection, which has the freedom to choose a ratio, but the one where the ratio is 1, so where you have scale 1 along the equator, basically gives you maps where areas of equal longitude and latitude end up being perfect squares. So the whole world is two squares. That's the plot carré. And we do that in R2, except that for other latitudes, we basically choose an aspect ratio so that 1 kilometer north is 1 kilometer east in the center. I don't think that quantum GIS does that. I always see these maps of Germany that are flattened like with 30-40%, and then I think, why? Why is this? Why should this? I mean, I always sort of send back papers that do that because I don't see any reason of doing that. You see a reason to do it?
Well, those are serious problems with every single projection.
Of course, I agree with that. Yeah.
I'm like, that's okay. And the simple features of data structures inherently cannot traverse this challenge. Like you can write implicit data structures that can be smarter and traverse those transformations, but in this context, I actually can't see the problem. I treat it as Cartesian when I pretend when I want to.
Okay.
To me, it's like it's about the meaning of things.
It has to do with meaning, of course. But
It's incredibly important, but please don't preclude decades of habits.
well, that's actually what I'm going to do. So the decades of work in my view are the decades of work that are done, that come basically from the legacy of GIS, Geographic Information Systems, that have done things in a certain way and have settled on this. And have settled on, okay, global data, we're gonna sort of look at that in the plane of -80 to 180 and -90 to +90. Whereas, of course, it is, it's global data, right? So it's from a globe. So if you have to project, you have to do something, right? So here's an example. If we take this map from Maps and push it into STSFC, into a simple feature, we get this thing that it basically connects this point to that point because it sees it as a polygon, right? And plots it as such. And so you get sort of south of this area, you get an area with no man's land because the Antarctica doesn't stop here, right? There are then other approaches to that, as Mike already demonstrated. That's the World Simple dataset that goes south, right? That goes at -180, takes a detour to the South Pole, then to the other side, which is the same point, but then at the other side of this projection, so from minus 180 to plus 180, so it's essentially the same point, and then goes back, right? So that on this projection, at least, we see land where there is land, yeah, which makes more sense. And then you end up with looking at other people's data, which is perfectly fine. So we have here some net CDF of sea surface temperature, which happens to be to run from not from minus 180 to 180, but from 0 to 360. So we plot some boundaries on top of that, and we see that that only works from 0 to 180, but not for the other half. Yeah, for the obvious reason that we need to sort of juggle with that, right? So these data are, of course, this world data set is here. It is just semantically not interpreted correctly. Yes, so it is there. It doesn't matter whether anything sort of on the Western Hemisphere, whether you give that negative coordinates or whether you give that coordinates larger than 180. It's exactly the same, right? But if you take the world view of the world is plot carré, then it doesn't work. So things don't work, whereas it's perfectly understood how it is and how it should work. Yeah. So the world is a sphere, and things are just somewhere. So this is actually something that I spend a lot of time on creating with R, and this turns out that doing these kind of things, these kind of projections, I think this is orthographic, right? Orthographic projections, where you basically see as if you see the world from a distance, is extremely hard with the software we have. Because if you project your polygons into this projection, and the polygon is not entirely visible, then it ends up in a polygon with a lot of missing values, right? That is what the projection methods do. So you get polygons that are kind of, you have coordinates and then they have missing values, and that's not going to plot. So entire countries basically fall off. So when you want to make something like this, first what you have to do is cut out the area that you can see. And that's not so hard to compute. But then you need to cut it out with cut routines that work in this space. And that looks very ugly. Yeah, that is, I mean, the code is on, it is like, the code is on GitHub and so on. But it's sort of a nasty thing to do. You wouldn't recommend it. It's really, I find it embarrassing.
It's really well solved in Topic.
I'm sorry?
It's really well solved in Topic.
Oh yeah, I can imagine. Yeah, definitely. Oh, it's solved in many places. That is not the issue. The issue is a little bit sort of the underlying assumptions that we make, other things that we see, that if we have a line string that crosses the date line, and we compute an intersection with the date line, then we see that there is no intersection, right? Because the intersection methods we use basically say, this is the world as we look at it. So this line crossing the date line doesn't even cross it. No, it crosses the entire world instead of the date line. And so this is, it just takes the logic the other way around. Then there is a function called strep_dateline, which is kind of, doing that. So it cuts basically this line at minus 180, but does that along a rump line, right? Doesn't do it, sort of follows constant latitude, so it's not like the shortest path line. So that's another thing that we discussed earlier this week. There is this simple feature model that says when we have lines or polygons, we have basically points that are connected by straight lines. But then when you have geographic data, what does a straight line mean? Right? The straight line in principle goes straight through the Earth, right? Doesn't sort of go over the Earth. Most things we want to depict kind of follow the Earth, right? So the most intuitive thing would be, at least in my perspective, would be a great circle, but the things that we see happen with the GIS sort of worldview is that we follow rump lines, which are not shortest paths or so, or also not great circle distances. So there is an issue. Polygons can be also cut in the same way, basically, and even standards like GeoJSON require you that nothing crosses the dateline. Whenever there is dateline in it, then you make sure that there's a cut in this thing, and it's two pieces. Yeah, so that already has this GIS plotting plot carré worldview in the data model baked. Yeah? So to preempt plotting problems, I assume, yeah? which is funny. So when writing SF and doing all kind of functions, I kind of ran into a number of things. For instance, that PostGIS has a type that is called geography, right, which deals with latitude, longitude, coordinates in degrees, and has a number of functions that support that support working that. For instance, computing areas, computing lengths, and so on, and does that using the sort of the shape of the Earth, which to me sounded like the better thing to do, as opposed to sort of assuming this projection when you do everything, yeah? Because that would be what we do now when you wouldn't do that. So it's at least it's in my view definitely better, but it's kind of half finished. Yeah, this was work that was done in sort of in contract for Palantir by all means. But it wasn't sort of, there are no functions that do intersections, for instance, for polygons and things. Then there's a lot of other technology that does things well, at least in my eyes, right. There is things like cesium, right, virtual globes that basically show you how things are without being bothered by you kind of looking at a pole or so, sort of that kind of thing. Google Maps 1 or 2 years ago sort of changed its default projection also from acknowledging that the world is round and being able to look at poles. It used to have this web Mercator thing, which kind of doesn't even cover the whole Earth. So that is some place. Another area is Google BigQuery GIS, which is a spatial database that only allows you to do data in latitude, longitude, and does everything in that space. So never makes any assumption about going to Poincaré or going to any projection. Just works in that space and does everything there, and does the whole set of functions that are prescribed by the simple feature standard on these data on that thing. And nicely they right. And so what is nice is that they came up with this library, the S2 geometry library, which is a C++ library that essentially gives you all the data structures and all the routines that do that. So that essentially powers all the BigQuery GIS infrastructure and also the things finding which tiles you have to address in Google Earth Engine, and so it's a combination of a mathematical system of doing all your geometry computations on spherical data, and combined with a spatial index that gives you very fast search and intersection technology. Yeah? So similar to what GEOS offers, but only offers in 2 dimensions, basically in Cartesian coordinates. So this is like something that I want to push into. I'm pushing it into R because I think that this is where I know how to do it. I think this is basically should push into everything, into all graphs, into every GIS, into graphs and quantum GIS and so on, because it is. I think the Poincaré view is kind of grow onto us historically, and Bob basically was there probably because geographers were not too much worried with global data, and maybe because they found it too complicated to do things on the sphere, and those days are over, right? Maybe it was computationally too heavy. It's no longer computationally too heavy. So we can do this. We can do. You see these things everywhere. So it's happening. Just there are, you could do a map view on top of cesium and have your stuff there instead of on top of leaflet. So this is a bit of a discussion to see where we can go with this project and what we can do there, and what you then have to, elementary things. What you have to rethink is things like bounding boxes, right? So these kind of things, a polygon that essentially wraps the South Pole, has a zero volume bounding box, yeah, because it doesn't because the maximum latitude or the minimum latitude is not included in the points. So it's basically you have to rethink a couple of concepts that are now everywhere. But I think that's feasible. So that's. But the thing is, are we going to sort of do this for all geographical data, or should we just do this as an exotic excursion? And you know, people know my opinion about this usually. Yeah? Mike, sorry. Keep in the old legacy GIS worldview. But you can always project to plot carré, and then things are identical to what you always did, because that is what we implicitly did. That's what we implicitly assumed. So if you project your data to this projection, sorry. I think new people don't understand this legacy GIS worldview. The thing is that data these days dominantly come as longitude latitude data. They no longer come in projected system. Data come unprojected. And so we are going to push onto everyone, yeah, that is fine, but we're going to, you know, we treat them as plot carré. Yeah, that's how we do everything. And I'm warning all the time, you know, you do an intersection, but you assume that things are plot carré, although they are longitude latitude. So I have no clue whether this goes wrong. And people see it so often that they're going to ignore that. Yeah?
It's massively important, but we just had a couple of years ago with disruption.
I agree that you should be able to do it both, but you are able to do both.
has been incredibly disruptive to workflows that we can standardize on this. That's the kind of, I mean, maybe that doesn't affect anyone, but this would be incredibly disruptive. In the way that you phrase, I see it as something new, and so I can choose to go that way.
Mm-hmm. Yeah.
I did want to add something technical. There's the concept of how do you read the model of universal?
Hang on, I'm going to give you the mic.
So you remember when Geom SF was being developed, had he kind of put out what is a universal representation of location, and he was sort of asking for that, like why do we care what the numbers are? But we're really like, well, it could be on a North Carolina datum, it could be on an Australian datum, you know, and there's no guarantee that you can say this is the numbers, and we don't care what you transform them to. And I think that's kind of the same problem, because if you project a coordinate and it's on the anti-meridian, it's the mathematics, it's the arctan will invert that, and you don't know if it's meant to be west or east. Mm-hmm. You know, and so it sort of implies you have to record that information with the coordinate. You know, when it's projected, it's wherever it is, but when it's inverted, we have to apply this other meaning, because it's about the topology of the shapes. Anyway, to me, it's new. It shouldn't be inserted into the older practices.
Okay.
Got a question. There's a function called st is lat long or lon lat in SF.
Yeah.
And if it is, then it behaves differently when you plot it, which I think makes plots slightly better when you go away from the equator. My question is, in the long run, well, in the short run, I imagine you're thinking of creating a package that will implement some of this stuff, but in the longer run, are you thinking of, if you've got latitude, longitude data, you will use the S2 methods on that in SF? So in the long run, are you thinking of kind of porting this functionality into SF?
Yeah, I think so. I think what now happens is if your data are latitude, longitude data are geographic coordinates, then when available, you use this LWGeom methods that are essentially the post-GIS geography routines for that. For instance, area and distance and so on already do that.
Yeah. I mean, I don't have really strong views on this, but I've seen many instances of people doing geometry operations on non-map data and then get wrong results from that. So that's destructive, and that has been destructive for a long time. So if it can
mitigate. True in projections as well. Like if you do not choose the right one, or you perform the operation in the inappropriate area or in the wrong one, I'm like, if we're going to do that because it's in longitude, latitude, you should do it all the time. It needs to be a choice. Like,
I think there will be a choice, and I'm sure it won't.
So the disruptive, the thing I think about disrupting is that right now, if you have geographical coordinates in R, and I think in most GIS systems, you essentially work with Cartesian coordinates in plat carré, in equidistant rectangular. You say the world is 2 squares, I'm going to look at it like that. So it's the implicit decision there, which is I don't see any point of doing that, which is historical. It has grown on us, but I don't think it's a good idea. And so as far as possible, I think whenever you have spherical coordinates, do spherical geometry. If you have projected coordinates, do Euclidean geometry.
that's wrong though. It's still wrong answers. I mean, the area is not right.
It's not. It might not be right, but it's at least it's better. It's more natural. It's the more natural one.
You're just hiding another problem from another direction.
Well, let's discuss this. Yeah? We have time after discussion that, yeah? No, one question, we will continue. But
I think it was always bad practice, and it still is bad practice to just pretend that geographical coordinates are flat. The only reason it is sometimes done is simply by mistake. It's not a choice.
well, it's not by mistake, it is by 30 years of history of GIS of doing this way.
I would say that good papers or good projects or good would just use a projection that is suitable for the area to represent flat coordinates. But otherwise, yeah, it's exactly as you say. Spherical coordinates go on a sphere.
Use a sphere, yeah. Okay, but so we have time to for who is interested in further discussing that and the implications and sort of what, discussing what bounding boxes are on the sphere and so on. Yeah, let's do a round of hands because nobody was assigned to this our discussion development workshop. Who is interested in joining me in the morning? Good, you are. So good. So some people are. That's great. Who is going to, you have a block this morning, right? Who's going to Madeleine this morning? Good, okay, that shouldn't run into capacity problems. And who's going to Veronica this morning? Good. In terms of reporters, let's do that also right now. Who is going to report my session in the afternoon? Briefly, my discussion. Recap that. Anyone but Mike. Who has, yeah, okay, good, look, yes, good, you're a good volunteer. Who will recap Madeleine's session in the wrap-up session this afternoon? Any volunteers? I just saw a lot of hands. Who was going to Madeleine's session? And now there are not very many fewer hands. Wow, wow. Yes, this is character. Ho, ho. So who is volunteering to do, recap, to summarize Madeleine's session of the afternoon? Good, perfect. Okay, thanks. Who will summarize Veronica's session this afternoon? It's your session this morning. This morning. Oh, I meant this morning's session. It's Veronica's, right? Yeah, I was still in the morning. Thank you. Good. So we have this morning. Then we have the afternoon program. Let me look at it. Where is? I can't read this. So the afternoon sessions are a repetition of Madeleine's block. Who is going to the afternoon session of Madeleine? Good. Who of you will report? On that? No. You're already reporting. No. Somebody who hasn't already reporting duties for today. Yeah. We need a reporter. No coffee break without reporter. Yes, great, thank you. Who is going to report on Marcus, his session? Who is going to Marcus, his session this afternoon? Yes, that is a nice group. Who will report on that? We're not grading the reports or so, right? It's not like... We are just testing your speaker qualities to select teachers for the next year's summer school, right? Who's reporting on Marcus, his session? Oh, great, Massimo. Who is going to Monk's session on air quality, air pollution modeling? That's a small session. Okay, who of you is going to report? Cool, perfect, thank you. Right, so I hope that a few more people show up and we'll then definitely go to Monk's session, which should be really exciting. There is one more thing that Michael posted in the Mattermost. You still have the microphone, right?